Module 16.2, Day 2, Proving figures are similar using transformations. Content standard. Given two figures, use the definition of similarity in terms of similarity transformation to decide if they are similar. Language objective. Work with a partner to list the essential components needed to prove a figure is similar to another. Finding a sequence of similarity transformation. In order for two figures to be similar, there has to be some sequence of similarity transformations that maps one figure to the other. Sometimes there will be a single similarity transformation in the sequence. Sometimes you must identify more than one transformation to describe a mapping. So then here are some of the transformations. We have a rotation. Let me erase that. So then it's a rotation, a reflection, a dilation, and a translation. Right. Okay, example 2. Find a sequence of similarity transformation that map the first figure to the second figure. Write the coordinate notation for each transformation. So here we're going from a quadrilateral A, B, C, D to E, F, H, and G. Okay, so let's find the coordinates for A. So the coordinates for A is at 1, 6, and we want to go into the coordinate for E. So then we find the coordinate for E is at 2.5 and 0, and the coordinate for B is at 5, 6, and we'll map to F. So the coordinate for F is at 1, 2, 3, 4, so 4.5 and 0, and D is at 2, 2. We'll map to H, and H is at 1, 2, 3, so 3, negative 2, and C is at negative 2 and 2, and we'll go into our G is at 1, negative 2. Right? Okay, so then those are the coordinates that we want to map to. So then here we have to do several transformations. So if we look at going from A to B, the distance is 4, and from E to F, the distance is 2. So then that means that we have a dilation, and the scale factor is 1/2. Right? Okay, and then okay, so then we start from A 1, 6, so then the dilation is 1/2, so then we go to, let's call this A prime, so it will be 1/2 and 3, and our B at 5, 6, go to B prime, so half of it is 2.5 and 3, and D is at 2, 2, so half of it would be at 1, 1, and C negative 2 and 2, and half of it will go to negative 1 and 1, but which is still not this point yet. So then we need to do some transformation. So we can say that we go from A prime to E. Right? So then A prime, we said it was a half and 3, and we need to go to 2.5 and 0. So then we can say maybe 0.5 plus 2 and 3 minus 3. Right? And let's try to see if it works for B prime. So B prime will go to our F. So then here we have at 2.5 plus 2, and 3 minus 3 will go to 4.5 and 3, which is matched with that, right? Okay, so let me clean up this mess. Right, okay, so here we can say that we have a dilation of 1/2, so we have our original point xy, and we want to reduce it to by half. And we also have a translation, and we have an original point xy, and we want to go over x plus 2.5. I need more room for this, so let me clean this up. We have a point xy will go to x plus 2.5 and y minus 3. Okay, so then these are our two transformations, a dilation of 1/2 and a translation of a x plus 2.5 and y minus 3. Right, okay, let's go on to part B. So then we have JKL, so then JKL, and we want to map this onto PQR, or PQR. Right, so we say that we can map the triangle JKL to triangle PQR with a reflection across the x-axis. So now that means that we have the point here. Okay, and then well, if we look at our distance from J to K is 3, and from P to R is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. Right? So then we see it's followed by a dilation, and followed by a rotation of 90 degrees. Okay, so then we have a reflection, x go to x and y go to a negative y, and then we say that we have a dilation, so a dilation of 3, so then it would be 3 times x and 3 times y, and we have a 90-degree counterclockwise rotation. Okay. Okay, and let's go on to number 8. For each pair of similarity, find a sequence of similarity transformation that map one figure to the other. Use coordinate notation to describe the transformation. So here we can have a go to here, so we can have a reflection. Right, and then have a dilation. Okay, so here we say that we have a reflection across the x-axis. So, okay, which means that we go from x, y over to negative x and y, and then we have a dilation. So here the distance is 1, we have 1, 2, 3, so from 1 to 3, so then the dilation, the k factor of 3, so we have a point xy will go to 3x and 3y. Okay, let's go on to this one here. Okay, and for this one here, we have a rotation, right? And then Well, if we look at our dilation, there's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So then the dilation with the scale factor of 6 over 4 or reduced to 3 over 2. And we have a translation that go from xy to the point x minus 3 and y plus 1.5. Okay, let's go on to this one here. So then for this one we want to go to describe the sequence of similarity mapping from JKLMN to VWXYZ. So to go from this figure to this one here. Right? Okay, so then here we can have a reflection across this axis. So let's call it 1, 2, 3, 4. So then x equal to 4, and then we have the distance from here to 1, 2, 3, 4, 1, 2. So let's do our translation first. So then you have a translation that this point J here is that 4, 4, and go to this point here, V at 11, 4. So then our translation going from x, y over to x plus 7 and y remain the same. And the distance from J to N is 4, this is 2, so then we have a reduction. So in our dilation, K is equal to 2 over 4 or reduced to 1/2. Okay, so let's say we have x, y will go to 1/2 x and 1/2 y. Right? Okay, so now let's go on to proving all circles are similar. Right? You can use the definition of similarity to prove theorems about a figure. Circle similarity theorem. All circles are similar. Example 3. Prove a circle similarity theorem. Given circle C with center C and radius R. Circle D with center D with radius S. Prove circle C is similar to circle D. To prove similarity, you must show that there is a sequence of similarity transformation that map circle C to circle D. Okay, so here's the proof. Through this translation, the image of circle C is point D. Let the image of circle C be circle C prime. The center of circle C prime coincide with point D. Transform circle C prime with a dilation with a center of D and the scale factor of R over S, where C prime is made up of all the points at distant R from point D. After the dilation, the image of circle C prime consists of all the points at distant R over S times R equal to S from point D. These are the same points that form circle D. Therefore, the transformation followed by a dilation maps circle C to circle D because translation and dilation are similarity transformation. You can conclude that circle C is similar to circle D. Okay, so that's the end of our 16.2 Day 2 notes. You are to work on in your bookwork, assignment number 7 through 12, and you are to finish your HRW and turn them in and copy down 16.3 Day 1 notes.